So this is another review day for the cumulative number 3. And what we're going to do mostly is work through the second half of that worksheet, except there's only one of each kind of problem. And so what I'm going to do is I'll make up a problem right now that goes with basically the topics that are left on that worksheet. Now, I had intended to have us test tomorrow, but as I disclaimed to this class here, I've decided to push it back. So tomorrow will be a practice test, and then the next day will be actually the cumulative. We have the luxury of being way ahead, so we can take that time and not mess up our review for the final. All right, so here's the thing we got to go over today. Bob, Saab, and bot are one little piece of it. Would you please write those out? And then try to remember, those were the horizontal asymptote rules. The horizontals are the horizontals, like y equals things. So I'm going to give you an example of a Bob and a Saab and a bot, and I want you to try to tell me what the horizontal asymptotes are. Okay? Now, with horizontal asymptotes, there's always only one. There can be multiple vertical asymptotes, but only one horizontal asymptote. Sometimes there aren't any. Do you remember which of these 3 kinds there aren't any asymptotes for? The bots. I said no bot as a way to remember that. Okay, so if it's a bot, bigger on top, then there are no horizontal asymptotes. I'll give you an example of one that's a bot. 2x squared plus 1 over x. That's bigger on top. There would be no horizontal asymptote in that one. Questions? Yes?
What would a function look like that had
2 vertical asymptotes. Okay. You know what? I'd like to do verticals in a minute. I'm going to stick to the horizontals for now. I promise. If you remind me of that same question in a moment, when we're doing vertical asymptotes, I will show you. All right. So next I want to do a Saab. Same on both. 2x to the third plus 3x plus 1 over 3x to the third minus 7. Some people feel like it's bigger on the bottom because of that 7. That's not it. How do you decide what you're looking at to see what's bigger and bigger on the bottom, bigger on the top? What are we looking at? We're looking at its degree. Do you get the degree of both of those is degree 3? So that's a same on both. What's the rule for Saabs? Well, this is the most complicated one I've been quoted as saying, and make you sob to figure them out, because we have to find a ratio of some things. What is it again? Ratio of the what's? The lead coefficients, yes. So therefore, this one would have y equals 2/3. Yes, it's a line at 2/3, horizontally. That's what this graph would have. Okay, and it's a ratio of this number and this number, which are the lead coefficients. Make sense? Okay, and the last kind is a bob. Here's one where it's a bob. That's a pretty simple bob. That's all it takes. It's bigger on the bottom. What's the rule for bobs? It's y equals whatever's on the outside. Good. And there's nothing on the outside, so it's y equals 0. And that is different than there's no answer. The answer is that it's y equals 0. That is a line at 0. If I had put a plus 7 out there, then it would be y equals 7. And this is one that you might find interesting. If I put a 7x out there, then it's y equals 7x. You can have slanted asymptotes. Now, we're not going to test you on that, but I just thought I'd tell you, because in honors pre-calc, we do slanted asymptotes, but for right now, it's just horizontal ones, so it still follows that rule for the bobs, though. So bob is whatever's on the outside. All right, now we'll talk about verticals for a minute. Here's an equation that would be a typical one from your test. Do you remember the old saying, if you can factor it, you should? Very good. Would you please factor that thing? And then some things will cancel, and then we'll be able to tell if you know what the verticals are. Vertical, it's all about the denominator. By the way, so is the domain. The domain is all about whatever makes this function work or crash, and that's all about the denominator, because if the top is 0, we don't care. It's if the bottom is 0 that it's got a problem. So verticals are related to domain. So I'm going to follow up with, once you get this thing factored, tell me the verticals and then tell me its domain. And I'd always like to start that with all reals except. Now you could write it with a number line. You could write it with parentheses and brackets and commas and U's and all that stuff. But you could also do it with saying all real numbers work except this. Excuse me. I'll give you a second to try those two, verticals and domain. All right, so you should have factored it to x plus 5 and x plus 1, and on the bottom, x plus 5 and x minus 5. Now, things cancel. Cancel, cancel. I'm going to write down this, what I call the resulting function. Just to clarify, this is not, uh-oh, all right. Then that was not factorable. I apologize. Just normally, I'm just kind of surprised that nobody caught that before now. You couldn't factor it until now. So go ahead, change it now and factor it. Otherwise, nothing would cancel, and then you wouldn't know what a hole was. So, sorry about that. I just made a 3 instead of a 2, and it caused you all kinds of trouble. I'm going to pause for a second while you catch up. Okay, so now, this is the function that if you were going to graph it, that's what you would graph. This made, what again? A hole. And the hole would have been at negative 5 comma what? I'll take a second and give you a chance to have some time. Where would the hole be? It would be where x is negative 5, yeah, but negative 5 comma what? Pausing for a second. So let's see if you came up with negative 5 comma, look where I put the negative 5. Did you put the negative 5 there? That tells you y equals negative 4 over negative 10. The negatives cancel. 4/10. I'm going to put 4/10, but we're all going to know that would have reduced to what? 2/5. Very good. Okay. The domain is all real numbers work except what? And I like to make a number line for these. You could do the all reals thing I was doing before, but you could also just say it can't be negative 5 and it can't be 5. But you, oh, that was 2 negative 5, sorry. But it can't, don't do this. That isn't shading anything in, it's saying nothing works. You've got to shade in where it does work. A lot of people had that wrong on your test, and I will mark it wrong again if you do that. You need the shaded in parts. That's saying it works everywhere except here and here. It makes it obvious. Those are the empty spots. All right. Now some people are like, but Mr. Server, one of those is a hole. True. But you can't put in negative 5 or it'll kill the original function. And you can't put in positive 5 because it'll kill the original function. It just does it in 2 different ways. It kills it with a hole, which means it's an empty spot in the function that doesn't exist. Or it does it with an asymptote. So this guy that's left after we cancel off the hole, that guy is telling us that there's a vertical asymptote at x equals 5. Okay, so the 2 things that are unsafe for your function, kind of like vaping, a little unsafe. The bottom part, whatever makes the bottom part 0. Okay, and one way it can kill you is with a hole, and the other way is if there isn't anything canceling, then it's an asymptote. All right, so this only thing that's left in this whole topic that I haven't talked about is how you'd graph this. So what would you graph? Well, first of all, you would graph not the original one. You would go look at this one, and you could make your best friend in graphing, which is a XY chart. Now, I like to make XY chart and put the hole on it right away because that's a point that's on the graph. It's just actually, weirdly, a point that's not on the graph. It's at negative 5 comma 4/10. There's an empty spot there. So negative 5 comma 4/10 would be like an empty spot right there. Where's the rest of the graph? Well, it'd be pretty smart to put asymptotes on here. We already know there's a vertical asymptote at 5. Verticals are up and down, and here's where 5 is. And then, where's the horizontal? Well, you got to ask Bob. Is this a Bob? Is it a Saab? Yes. If it's a Saab, it's a ratio of the lead coefficients. Whether you use this one or this one, either way, the ratio of lead coefficients is 1 over 1 is 1. So if I were to bust out a graphing application, I would see that at 1, there'd be an asymptote. Now notice that left my hole as just underneath that dotted line. That means this graph must go like this. And the other part probably goes like that, but I'm not going to do that until I check a point over there. So let's try to get 1 point over there, and we'll figure out if it really goes like this. All right, so I gotta find a few points. Would you take a minute and use this function right here and find, just for overkill, find 3 points. Hint, the x-intercept is where y is 0. That's a nice point to find. Or the y-intercept, which is where x is 0. It's another nice point to find. This one was the hole. Find me 3 other points. I'll pause for a second while you give that a try. All right. So if I take my own advice and try to find the y-intercept, which is where x is 0, I get 0, comma, what's left? Y equals negative 1/5. Y-intercept is where x is 0, negative 1/5, so there's a dot like right about there. Okay, and then how about the x-intercept? That's where y is 0. Well, then x would have to be negative 1. Do you get how I did that one? If I knew that this function needed to equal 0, I made the top 0. So I made y equals 0, and then I figured out what x would have to be by putting a 0 right here. Then that would have to be a negative 1, so it could be 0 over anything, which is 0. Now, do you need to do that one? No, you can pick any points you want. All right? What if you really feel like putting in positive 1? You want to see what you get. Fine, do it. Put in a 1, put in a 1, and you get 2 over negative 4, which is negative 2/4, which is negative 1/2. So 1 comma negative 1/2. And I've got a good enough picture now here where I can see where it's going to go. Notice it gets closer and closer to the asymptote lines, never touches them. Now I'm going to take one more point, which is going to be on the other side of this line, because I think it's up here, but I don't know for sure. So I'm going to put in something past the asymptote. The asymptote was at, let me think, it was a horizontal asymptote, no, vertical asymptote at 5, so I should put in something bigger than 5, like 6. So if I put in a 6, I get 6 plus 1 is 7 over 1, which is 7, 6 comma 7. It is up in that circled area. Yay, I guessed right. Now I know for sure, though. There's a dot there. So it must get closer and closer to the asymptotes and never touch them. And there we go. That's the graphing part. Now that covers everything. But I'm not deluded enough to think that you understood everything. It is all review, but it's easy to forget some of this stuff. So again, I don't really want to go do a whole review problem on everything. There was only one kid who came up and asked me a couple, but one question that was new that I hadn't covered, and it was like this. He said, there's this hole here, and there's another hole like here, and I'm supposed to write the equation for this. He's like, I know how to find the holes, which is great, but he didn't know how to find the equation for the rest of it. All right, so imagine for a moment that's the question. They say, what's the equation for that? This is not an easy one. All right, first, would you agree that it starts with something that doesn't have holes in it? In case you forgot this, I know it's been like 2 weeks, maybe 3 weeks, you could argue, since we did this. You act like the holes aren't there. And you say, what's the equation now? And it looks to me like that's got a slope of 1, and it looks to me like it's not at 0. It looks like it's touching at 1. And so y equals 1x plus 1 would be a good guess on what that equation was without holes. Do you get what I just did there? You have to be able to give me an equation for a line that doesn't have the holes. And it has to do with the slope and the y-intercept. Now I need to add the holes in. So I'm going to rewrite it, y equals x plus 1 with parentheses around this. Why do I want parentheses around that? So that when I put the hole in, that the hole will cancel off and leave me my x plus 1. My hole is at 7. Notice if I want to be 7, I use x minus 7. Like that 7 is the 0. The factor for it would be x minus 7. And then there's one more hole at 4. I hope you already figured this one out. X minus 4, x minus 4. There's your equation. Most kids figure out this part because they're like, I know there has to be something on top and bottom that cancels. So they get that there should be a hole. But it's hard to figure out the other part. So once you've got these two circled parts done, it's that part that's hard. So just go back to basic algebra. Here's one more that's like that, except without any help from me. I'll tell you that the slope in this one is 2. You'd be able to tell by how much rise and run there was. And let's let me move it up a little bit so it isn't so much like last time. And let's say that the y-intercept here is at 5. But if this is even in this unit, then it needs to be a hole. The hole will be right there at -1. There's an empty spot. I guess I can do better. I'll erase a spot on the line and then make the hole go over the line. There. There's a hole right there. Write the equation for that one. I told you its slope. I told you its y-intercept. And I said, try to write the equation without the hole first. All right, pause for a second. Let me give that a try. All right, let's say that you had written, ignoring the hole, y equals 2x plus 5. Raise your hand if you had that as part of your answer. Okay, good. That's a good start. Then we go back and reconsider the hole is at -1, so then don't forget the parentheses. Parentheses around this. And then the hole, x, and then where's the hole at? -1, so plus 1. Plus 1. There's your final answer. All right, and to see if you tie it all together, does this one look like a bob, Saab, or a bot? A bot. And therefore, what kind of horizontal asymptote should it have? None. And it doesn't have one. Cool. How about vertical asymptotes? Doesn't have any, because the one thing that seems like it would be a vertical asymptote is actually a hole. Okay. All right, good. Okay, so the job for tonight is just to try to do a really good job of the worksheet. Do the rest of the problems on the worksheet. Remember that I'm available Wednesdays during Mass. You can come in. No invitation needed. Just show up. And remember, though, that the test isn't actually tomorrow. We'll take a practice test tomorrow. And then the real test will be the next day. Okay? All right. That's all I have for you for the video for today.